To understand volt-ampere calculations for motor feeders, we need to understand how to calculate volt-amperes for continuous motors. Volt-amperes equals volts times amps times 1.732. Volts is the voltage and amps is the full load amps. Full load amps for continuous motors can be obtained from table 430.150 for motors with nameplate full load amps given. If full load amps is not given, it can be estimated using the following rule: full load amps equals horsepower times 746 divided by volts times efficiency. For feeders with mixed continuous and non-continuous motors, the volt-ampere calculation becomes more complex. The full load amps for each type of motor must be adjusted to account for their duty cycle. For intermittent duty motors, full load amps is multiplied by the percentage given in table 430.22. For varying duty motors, full load amps is multiplied by the percentage given in table 430.22. Given a 10 horsepower 3-phase continuous motor with a full load amps of 30.8 amps, two 5 horsepower 1-phase intermittent duty motors with a full load amps of 30.8 amps, and 3 2 horsepower 1-phase varying duty motors with a full load amps of 24 amps. Let's determine the branch circuit overcurrent protection. The largest motor, the 10 horsepower motor, has a full load amps of 30.8 amps. 30.8 amps times 250% equals 77 amps. Branch circuit overcurrent protection is 80 amps. To determine the feeder circuit overcurrent protection, we add 80 amps plus 2 times 26.18 amps plus 48 amps, which equals 208.16 amps. The feeder circuit overcurrent protection is 200 amps. Total volt amperes using method of using the motor table full load amps is calculated as follows. 208 volts times 1.732 times 30.8 amps plus 2 times 208 volts times 26.18 amps plus 3 times 120 volts times 48 amps plus 48 amps times 25%, which equals 39,279 volt amperes. This is the correct method for calculating volt amperes in this case because the table full load amps values are adjusted for duty cycle. The 25% addition for the largest motor is only applicable to continuous motors. It should not be applied to intermittent or varying duty motors. If nameplate full load amps is not available, the estimated full load amps value should be used for calculation. Looking at the initial scenario with 110 horsepower 3-phase 208 volts continuous motor at 30.8 amps at 100%, 2 5 horsepower 1-phase 208 volts continuous motors at 30.8 amps at 100%, and 3 2 horsepower 1-phase 120 volts continuous motors at 24 amps at 100%, the calculations proceed as follows. 30.8 amps times 250% equals 77 amps. Use an 80 amp branch circuit breaker per 430.52. C1 and 240.6. The feeder circuit breaker is calculated as 80 amps plus 2 times 30.8 amps plus 24 amps, which equals 165.6 amps. Use 150 amp feeder breaker per 430.62 and 240.6. Total feeder circuit volt amperes equals 208 volts times 1.732 times 30.8 amps plus 2 times 208 volts times 30.8 amps plus 3 times 120 volts times 24 amps plus 30.8 amps times 25%, which equals 32,557 total feeder circuit volt amperes. In the second scenario, the motor configuration is the same except the 2 5 horsepower 208 volt 1-phase motors are now classified as intermittent due to 15-minute rated motors, and the 3 2 horsepower 120 volts 1-phase motors are now classified as varying duty continuous rated motors. For the largest motor comparison per 430.24 exception 1, we have the following. The 10 horsepower 3-phase 208 volts motor at 30.8 amps at 125% continuous equals 38.5 amps per 430.24 exception 1. The 5 horsepower 1-phase 208 volts motor at 30.8 amps at 85% intermittent duty equals 26.18 amps per table 430.22. The 2 horsepower 1-phase 120 volts motor at 24 amps at 200% varying duty equals 48 amps per table 430.22. Therefore, we have the following. 110 horsepower 3-phase 208 volts continuous motor at 30.8 amps at 100% per table 430.150. 2 5 horsepower 1-phase 208 volts intermittent duty motors at 26.18 amps at 85% per table 430.22. 3 2 horsepower 1-phase 120 volts varying duty motors at 48 amps at 200% per table 430.22. 48 amps times 250% equals 120 amps. Use 125 amp branch circuit breaker per 430.52. C1 and 240.6. The feeder circuit breaker is calculated as 125 amps plus 2 times 26.18 amps plus 30.8 amps, which equals 208.16 amps. Use 200 amp feeder breaker per 430.62 and 240.6. The total feeder circuit volt amperes by motor table full load current is calculated as follows. 208 volts times 1.732 times 30.8 amps plus 2 times 208 volts times 30.8 amps plus 3 times 120 volts times 24 amps plus 30.8 amps times 25%, which equals 32,556 total feeder circuit volt amperes. By motor rating, the calculation is as follows. 208 volts times 1.732 times 30.8 amps plus 2 times 208 volts times 26.18 amps plus 3 times 120 volts times 24 amps plus 30.8 amps times 25%, which equals 30,634 total feeder circuit volt amperes. By motor duty, the calculation is as follows. 208 volts times 1.732 times 30.8 amps plus 2 times 208 volts times 26.18 amps plus 3 times 120 volts times 48 amps plus 48 amps times 25%, which equals 39,279 total feeder circuit volt amperes. Therefore, to reiterate, for continuous motors, full load amps can be obtained from table 430.150. If full load amps is not given, it can be estimated using the formula full load amps equals horsepower times 746 divided by volts times efficiency. For non-continuous motors, full load amps is adjusted based on the duty cycle per table 430.22. For intermittent duty motors, full load amps is multiplied by the percentage given in table 430.22. For varying duty motors, full load amps is multiplied by the percentage given in table 430.22. When calculating the branch circuit overcurrent protection, use 250% of the largest motor's full load amps per 430.52. C1 and 240.6. For feeder circuit overcurrent protection, sum the branch circuit overcurrent protection of the largest motor with the full load amps of the other motors per 430.62 and 240.6. For total feeder circuit volt amperes, calculate each motor's volt amperes using the adjusted full load amps values based on their duty cycle. Then sum the volt amperes of all motors to find the total feeder circuit volt amperes. Remember that the 25% addition for the largest motor is only applicable to continuous motors and should not be applied to intermittent or varying duty motors. If nameplate full load amps is not available, use the estimated full load amps values for calculations. The formulas used are volt amperes equals volts times amps times 1.732 for three-phase circuits and volt amperes equals volts times amps for single-phase circuits. When dealing with mixed continuous and non-continuous motors, adjust the full load amps values for non-continuous motors based on their duty cycle using table 430.22 before performing any volt-ampere calculations. This ensures accurate results for both branch circuits and feeder circuit sizing and protection.